Hello again. Where? Oh, duh. I'm clicking on the wrong one. Okay, welcome to a super short assignment. Yay! Okay, so this deals with the binomial theorem and then something called Pascal's triangle. And Pascal's triangle is a formula. No, excuse me, it's a pattern. So this guy named Pascal, he said that whenever you expand a binomial, it always follows the same pattern based off of your exponent. Okay? So if you have the fourth row, that's what's saying the fourth row of Pascal's triangle, and I'm just going to kind of refer to an example here. Okay? This is So the top of Pascal's triangle deals with if you had it to the zero power, it always starts 1. So if you have an expression that says m plus n to the zero power, it starts with a 1 at top. Let's say you have m plus n to the first power. Then you have two more ones. And it's the same pattern the whole way down. And what they're doing is they are multiplying. No, they're adding. Excuse me. They're adding. So a 1 and a 1 here because there's nothing to add to from the previous one. And then if we do it again to the second power, now we fill in the 1 for the outside, we add the 2 in the middle to give us 2, and then we have our 1. You'll always have like a border of 1s to make that pyramid. If we did it to the third power, we add. So put our border of 1, add, add, and then the next border. We have it to the fourth power. So we're going to put our border there. We're going to add, and add. So this tells me all of the coefficients for if I would expand this binomial. Now we got to deal with the numbers, the actual variables inside. All of the variables start with a pattern, okay? So since it's positive, we don't need to worry about negatives anywhere. So we start with the m, and the m gets that fourth power right away. So when you start this, the first variable gets whatever the exponent is. And then you're going to add it to your variable is then going to start going down. And as it goes down, that's when the other variable hops in. Okay? My m is still going down, but now my n is starting to go up. And it's just a pattern here. Now it's just this one. My n is to the third. And lastly, n to the fourth. And now I'm just going to bring in those coefficients that I already got from the pattern. This is going to be 1m to the fourth plus 4, I'm going to move that there, m to the third n plus 6m squared n squared plus 4, and it's just following a pattern. That's it. Okay? So it follows that same pattern. And you'll see it. So you don't need, you could just type in to the fourth. I'm really glad we're doing odds because this assignment is kind of a pain in the butt. Plus 4m to the third n plus 6m squared n squared plus 4mn to the third plus 1 n, oh excuse me, if we could just do n, same thing, n to the fourth. Check answer, and we are correct. So that's what the binomial theorem is. It follows the pattern. Okay, now we're dealing with factorials. And factorials are kind of cool because all they mean is that exclamation point means you're multiplying. So we're going, if it's 5 exclamation point, that means we're going 5 times 4 times 3 times 2 times 1. And then on the bottom, 3 times 2 times 1. And what's cool is when you expand out a factorial like that, whatever's on the same top and bottom cancels itself out. So we're just left with 5 times 4, which is 20. Next one. Okay, so we want to use the formula. So we're just looking for which one follows the pattern. Now we need the 8th row of Pascal's triangle. Okay, so it's going to have some pretty funky coefficients there. So you could write it out. It's not too bad to write out. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7. We're almost there. 15 plus 6. Oh boy. Okay. 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 15 plus 6 is 21. 35, 21. Nope, 35. See, this is where you have to be careful. It's almost like it would be better to just look up a picture of Pascal's triangle. 1, 8, 21 plus 7 is 28. Oh, I knew that. 21 plus 35 is 56. 0, 70. 56. It helps because it's just a mirror image of what you've already done. Okay, so we're in the 8th row. Okay, it starts at 0, so 1, 2, 3, all the way down. So you just need to find which one has these coefficients. So 1, 8, 28, 56, 70, 56, 28, 8. Oh, it's missing the 1, so it can't be that one. 8, 28, 56, 70, 56, 28, 8, 1. Looks like this is our contender. Yay, we did it. Okay, number 7. Cool. Oh my gosh, guys, this is awesome because we are. Oh, nope, I didn't mean to do that. We already have our triangle up here. They want the 7th row, so we need to find the ones that match this row. So 1, 7, 21, 35, 35, 21, 7, 1. This one works. And I don't think any of these others do. Nope. Nope. So it's A. I love this. Check answer. Booyah. Done. Okay, this one, we want to find the 6th term of the expansion. So we already have our row. Now we're just dealing with the pattern of the expansion here. So this one, when it expands, it's going to have 7 different terms. And I know that, oh no, it isn't. It's going to have 1, 2. I can use the triangle to help with that. So when it expands fully, it's going to have 1, 2, 3, 4, 5, 6, 7, 8 different terms. So we want the 6th term. So that's going to be 1, 2, 3, 4, 5, 6. It's going to be this one. So it's going to have a coefficient of 21. And the pattern that would happen, okay, you got to think about it. The W starts with 7 and then it goes down. Okay? So 7, 6, 5, 4, 3, 2. So the 6W is going to be squared. And then the Z would be going up. And the z doesn't start going up until the second term.